Hello students, today we are going to discuss about the first topic and as well as important topic, units and measurements. So in this units and measurements topic we are going to discuss about what are the physical quantities, what are the types of physical quantities and what are the dimensions and what are the measurement values that we are taking. So first of all, take about the physical quantity. What is the physical quantity? Physical quantity is nothing but the quantity which can be measurable. The quantity which can be measurable, that is called physical quantity. Mass can be measurable. Mass is a physical quantity. Length can be measurable. Length is a physical quantity. Time can be measurable. Time is a physical quantity. Speed can be measurable. Speed is a physical quantity. What are the quantities we are able to measure? Those are called as simply physical quantities. Generally, the physical quantities can be categorized into three parts. What are those? Fundamental physical quantities. Fundamental physical quantity. Before that, physical quantity. What is a physical quantity? Means the quantity which can be measurable. The quantity which can be measurable, that is called simply physical quantity. What are the examples? Examples are mass, speed, time, velocity, force, etc. These all many few are there we can able to measure. Those are physical quantities. What are the quantities we are not able to measure? What are the quantities we are not able to measure? Can you say? Yes. Some quantities we are not able to measure. Our feelings, sadness, happiness, those feelings we are not able to measure. What we are able to measure, that we can name as physical quantities. These physical quantities can be categorized into three parts. First, fundamental physical quantities. Fundamental physical quantities. Fundamental physical quantities. What are these fundamental physical quantities? The physical quantities which are independent on other physical quantities. The physical quantities which are independent on other physical quantities. Those are fundamental physical quantities. Let's see, we have 7 fundamental quantities. 7. The number is 7. What are those? First one is mass. Next, the second one, length, time, amount of substance, luminous intensity, electric current, and as well as last, temperature. These are the 7 fundamental physical quantities we are using. 7 fundamental physical quantities. What are the unit? What is the unit? Unit is nothing but a standard measurement. Unit is nothing but standard measurement. So mass we are using to measure the mass. Unit is kg. We are using the unit of kg. Length, meter. Length we are using the meter. Time we are using second. And amount of substance, the unit we are using mole. Luminous intensity, candela. What is this luminous intensity? Means like a light. And this is amount of substance like gases we are measuring in moles. And electric current, ampere. Temperature, checking in Kelvin. Temperature we are checking in Kelvin. So what are those? Mass, length, time, amount of substance, luminous intensity, electric current, and as well as temperature. These are 7 fundamental physical quantities. What are the fundamental physical quantities? Means the physical quantities which are independent on other physical quantities. The physical quantities which are independent on other physical quantities. Those are called fundamental physical quantities. These are 7 types. Next, we have second category is derived physical quantities. What are those? Derived physical quantities. What are these derived quantities? Generally, these derived quantities means we can say that which are depends on other physical quantities, which are depends or which are derived from the other physical quantity, which are derived from the other physical quantities. Those are called simply derived physical quantities. Which are derived from the other physical quantities, those are we can name as derived physical quantities. So what are those? Many are there, but we will discuss few. First, take area. Area is a depends on length and breadth. Length and breadth. So length into breadth. Length is the fundamental. Breadth also nothing but length only, na? Is measuring distance wide. So that's why the area is a derived quantity. If we are using the length general unit, we are using meter into meter, meter square. General unit, meter into meter, meter square. Next, volume. Volume, length into breadth into height. Volume, length into breadth into height. Length into breadth into height, meter cube. What we can able to use? Meter cube. Next, area, volume and density. Density means generally what we are taking? Mass upon volume. Mass upon volume. Mass, kg. Volume, meter cube. Why these are called derived? See here, these are depends on other quantities. For example, density. Density depends on mass and also volume. That's why density is a derived quantity. But mass is independent on any other. So that's why mass is a fundamental quantity, right? Next, speed. Speed. Speed is nothing but which quantity? Speed also derived quantity. Why? We are defining it. Distance upon time or distance travelled by the body per unit time. Distance travelled by the body per unit time. We are taking that. So distance, meter, time per second, meter per second, meter per second. Next, velocity. Velocity. Velocity also displacement upon time. This is also we can take as meter per second, meter per second. Next, acceleration. Many are there, many are there. Acceleration. What we are checking? Velocity upon time. The unit is meter per second square. Meter per second square. So what are the derived quantities? Derived quantities means the physical quantities which are depends on other quantities, or the physical quantities which are derived from the other quantities. Those are called simply derived quantities. And one more, two more you can take. Force. Force. Force is nothing but mass into acceleration. Kg meter per second square. Kg meter per second square. Force unit. Next, momentum. Momentum. Mass into velocity. Mass kg. Velocity meter per second. So these are all, we can say that many are there. Energy, work, power, and as well as potential, capacitance, resistance. So these are all concerned derived quantities only, because these are all depends on other physical quantities. Next, third category is we have supplementary physical quantities. Supplementary physical quantities. What are the supplementary physical quantities? So here, fundamental means the physical quantities which are independent on other quantities are called fundamental quantities. The physical quantities which are depends on other quantities are called derived quantities. And supplementary, the physical quantities which are neither fundamental nor derived, means it's not belongs to fundamental, it's not belongs to derived. Those are called supplementary physical quantities. Those are called supplementary physical quantities. What are the supplementary physical quantities? Have a look. Plane angle. Plane angle. What is this plane angle and what is the unit of that? The unit is radian. radian. What is this plane angle? Generally, whatever we are using the angle of the triangle, total angle, sum of the angles in the triangle, 180 degrees. Sum of the angles in the square, 360 degrees. So whatever the angle we are using, and that is a 2D. The plane angle is 2D, two-dimensionally we are measuring. For example, angle of the sector. This angle if you are checking. And this is called arc length. And this is called radius. So this angle, how we are measuring? The theta is equal to, angle is equal to simply arc length upon radius. Arc length upon radius. And how we are measuring that? By radian. Next, in the plane angle, first one. Second one is solid angle. This solid angle is, to us, it is a 3D-dimensionally we are checking. And especially the angle of the cone, you can observe the cone ice cream, how it will be. The angle is in 3D shape. So that angle, what is the unit we are using? The unit is steradian. What is the unit? Steradian. This is the plane angle. And solid angle. Solid angle means we can take a cone here. Cone means generally we can draw the cone diagram in this way. Yes. Here what is the angle? That angle we can name as solid angle, 3D. Then how we are measuring the solid angle? The solid angle we can measure like area upon surface area upon square of the radius. Surface area upon square of the radius. That's we are measuring in solid angle. So next we have unit. What is unit? Unit is the standard measurement of the physical quantity. Unit is the standard measurement of the physical quantity, and which is we are using as the reference to measure or to compare with another physical quantity in another system. We are using the unit. So what is the importance of the unit? Yes, for example, if I am asking what is the length of this object, which unit generally you can able to use? Yes, so like centimeters or else meters or kilometers, what you are using, which is suitable, which is comfortable? Centimeters is comfortable. Yes. In case if I want to measure the distance from here to somewhere in the market, somewhere, so the distance we have to be able to measure in meters. And distance between two cities we can able to measure in kilometers. Means it is a standard measurement and also useful to comparison with the another systems. So here let's say we have some system of units. What are the system of units? Generally we have different systems. In that also we are taking basic units. Very basic quantities are. Generally fundamental physical quantities are there. In that also basic quantities are there. Mass, length, time. By using of these three, we are dividing the equations or we are dividing the systems. What are those? First of all, I am taking here mass. Length I am taking CGS. So length I am taking, and then mass, and then time. And here I am using the systems. First system is CGS system. CGS. C stands for centi. So in length we are measuring in centimeters. So that's why C stands for centi. Mass, M stands for gram. Time, second. So C, centimeter. G, gram. C, second. So see here, centimeter, gram, second. That we are using in CGS, first letters. And next, F, P, S. F, we are taking in foot. P, pound. P, P, pound. S, seconds. F, length we may measure in foot, and as well as mass we may measure in pound, and time we can measure in seconds. Next, MKS. Meter. M stands for meter. And mass, kg, kilogram. And time, seconds. So these are the generally systems and as well as the physical quantities, system of units. These are the generally what are the systems we are using. Those are the system of units. What are those? CGS system, FPS system, MKS system. But one more system is there, that is SI system. Means it is the system of international units. Why? What is the purpose of this? So generally if we are going to the Britain, they are measuring the masses in pounds. Pounds they are using. And at the same time in India, we are using in kgs, kilogram. So that's why different countries are using different units. Then internationally they need to use one particular unit of system. That's only SI. SI means system of international units. SI means system of international unit, which is similar to MKS system. So see here length we are measuring in meters, mass we are measuring in kgs, time we are measuring in seconds. In CGS system we are taking length meters and mass kgs. Time in seconds only we are using in SI system. SI stands for System of International Units. Next, we'll see multiple and submultiples of the SI units. Multiples and submultiples of the SI unit means very important here. So, see here, what are the multiples and submultiples we are using here? For example, if you have 10 power 1, that is called for you deca. What we are named as it is 10 power 1 multiple, and this is a prefix, and the symbol we can use capital D. 10 power 1 deca. 10 square hectare. We are using the symbol capital H. 10 cube kilo. 10 cube kilo. You are using capital K. 10 power 6 mega. Capital M. 10 power 9 giga, capital G. 10 power 12 tera, capital T. 10 power 15 peta, capital P. 10 power 18 hexa, capital P. So these are the some multiples, prefix and symbol. Yeah, because sometimes we are getting kilometer. Kilo stands for 10 cube meters. And gigameters. Giga, 10 power 9 meters. Nanometers, picometers. So whatever, what is the purpose that we are using here? These are the positive values. Let's at the same time see the negative values. 10 power minus 1, submultiples. 10 power minus 1, we can call as decimal. Deci, representing with small d. 10 power minus 2 centi, representing with small c. 10 power minus 3 milli, representing with small m. 10 power minus 6 micro mu. 10 power minus 9 nano. 10 power minus 12 pico. 10 power minus 15 femto. What is that unit? 10 power minus 18 atto. Symbol small a. So these are the multiples and submultiples. What we are using? Nanometer, or else a picometer, micrometer, millimeter, centimeter, decimeter, whatever we are using from here only. These are the multiples and submultiples of SI unit.